In 1572, people across the northern hemisphere saw a star appear in the constellation Cassiopeia. It quickly grew brighter than Venus, and for 2 weeks, you could even see it during the day. After about 18 months, the new star faded away. Of course, we now know it wasn't really a new star, it was an old star, 13,000 light years away, exploding as a supernova. It's now known as Tycho's supernova, after the famous astronomer who tracked its progress. Today, all that's left of the explosion is an expanding cloud of leftover gas and dust. But in 2008, modern-day astronomers got a rare opportunity to see a rerun of the main event when a second pulse of light reached Earth. These kind of repeat signals are known as light echoes. We've seen them from a few different types of bright flashes in space, but most of the ones we've spotted have come from supernovas. And by studying them, astronomers have been able to resolve some decades-old questions about what happens when stars explode. Light echoes work a lot like regular echoes, the kind you hear when sound bounces off a surface like a wall or a cliff. Light waves can also bounce, but over Earth-sized distances, it's virtually impossible to notice the delay from bouncing light without special equipment, because the speed of light is just too fast. But when light reflects off something light years away from the original source, like a cloud of dust, the delay can amount to years. That's exactly what happened in the case of Tycho's supernova. The more recent pulse came from the same explosion we saw in 1572, but instead of traveling straight to Earth, it left the star and hit some dust clouds at just the right angle to bounce back toward Earth. The detour added 436 years to its journey. It's hard to predict exactly when and where a supernova's light echoes will happen, but when conditions are right, they appear like fuzzy arcs around the spot where stars have exploded in the past. Once we find them, light echoes can tell us all kinds of secrets about the supernovas they come from. For one thing, they give us multiple chances to experience the same phenomenon. Normally, when we study supernovas, we're only ever looking at a tiny slice of the entire process. Even if we catch a supernova right as it's exploding, after it fades, it can take hundreds of years before the remnant spreads wide enough for our telescopes to resolve it. It's kind of like trying to figure out the plot of an entire movie by watching just a few seconds. But with light echoes, scientists can examine the same supernova at 2 different times in its life. With Tycho's supernova, for example, researchers used the light echoes to study the explosion itself and compared it with what we can see of the supernova's aftermath. With the new data, they were able to confirm what type of supernova it was, which astronomers had been debating for decades. Turns out that it was one of the most common, a type 1a. Astronomers think 1a supernovas happen when the gravity from a white dwarf, which is a super dense star, either pulls in material from a second star in the same system or merges with another white dwarf in the same system. Either way, once the white dwarf absorbs a certain amount of mass, it explodes. Light echoes can also give us 3D vision. We usually only see light that's emitted from a supernova in one direction, toward us. But if dust is oriented just right, it can reflect light coming from different parts of the star. In 2011, astronomers used light echoes bouncing off 3 different clouds of dust to get a 3D picture of the supernova Cassiopeia A, which appeared in the sky around 300 years ago. We'd known for a while that the leftovers of the explosion looked pretty lopsided, but it's always hard to know if a supernova's asymmetry came from the explosion itself or if it happened later as the debris passed through space. We're still not totally sure how Cassiopeia A got so lopsided, but the light echo showed a bunch of asymmetry right around the time of the supernova, which means it might have happened during the explosion itself. You can use light echoes to see what the space around a supernova is like too. It's basically echolocation, except instead of bats bouncing sound waves off of their surroundings, there are enormous explosions bouncing light. Based on where the light echoes are coming from, we can tell where the dust is and how it's oriented. We can even measure its thickness based on how sharp or blurry the reflection is. And the color of the light can give us some clues about what type of dust it's bouncing off of. In each rerun we watch through a light echo, we get a new perspective and a new chance to explore the past with better instruments and more knowledge. And from these echoes, we can learn more than we ever would from just one look. Thanks for watching this episode of SciShow Space. If huge explosions in space are your thing, you might want to check out our video about how astronomers accidentally discovered the biggest explosions we've ever seen in the universe, gamma ray bursts.